is Mr. Gibson again. Showed you guys how to solve exponential equations. Now I'm going to show you all how to solve log equations, logarithm equations, okay? We're using the same inverse principle here, that if you plug in the inverse of a function into that function, they basically cancel each other out and you get x, okay? Again, an exponential is the inverse of a log, okay? So if we plug in a log into the exponent of an exponential, log of the same base, well, they're going to cancel out and you'll just be left with x, okay? So let's look at a few examples here. One important note as we go forward, a log of any type, a log of 0 of any type does not exist, okay? Okay, this is not possible. Okay? Alright, because you can't take an exponent of, you can't take the exponential of anything and get 0. Okay, so this will come up every once in a while. And that's the same thing with negatives. Alright, so here's an example here, kind of the most basic example. So I have log base 5 and log base 5. So what we need to do is we need to get rid of these logs. Alright? The way we do that is by putting each side into an exponential of base 5. Okay, so what's going to happen here? These are going to cancel. And I'm left with 1 minus 2n equals negative 3n minus 9. Well, now we're just going to solve like we solve any other equation. I'm going to add 3n to both sides. Subtract 1, subtract 1. Okay, I have 1n equals negative 10. So n equals negative 10. Okay? Alright, so the main thing to know here is, look, I just put these logs, these expressions, into the exponential, okay? An exponential of base 5, that cancels it out, and and then you just solve like a normal equation from there, okay? Here's another example. Again, base 20, so I'm going to use exponential of base 20, put it inside of there. These are in the exponents again, so these will cancel because they're inverses of each other. I'm left with 2a equals negative 2a. Alright, so I'm going to add 2a to both sides. And I get 4a equals 0. Divide 4, I get a equals 0. Uh-oh, that's a problem. Alright, that means that if I plug this back in, okay, I would get log base 20 of negative 2 times 0, which is log base 20 of 0, which does not exist. Okay, that doesn't exist, so we actually have no solution here. So this is important that you need to check to see whether this will work, okay? Whatever answer you get, you need to plug it back in and check and make sure you don't get a 0 or negative number, okay? Alright, here's an example where you're actually going to have to use those log properties, okay? So we're going to have to use a couple of them here. So let's see. First of all, this is a minus, so we're going to use the quotient property, okay? So we're going to go, or the subtraction here. So we're going to have log base 4, and we have 2x squared over 2 equals 3, okay? Alright, so that's what we started out with. Now, let me get rid of this log base 4. So I'm going to raise both sides, okay, into the exponent of something with 4, alright? These will cancel. I have 2x squared over 2 equals 4 to the third, which is 64. Double check that because my mind is blank right now. Yep. Okay. So now we're just going to solve for this. I'm going to multiply by 2. Okay, and again, notice that 4 to the third equals 64. That's where I got the 64 from. 64 times 2 is 128. That was silly because I could have just canceled the 2's because what happens here? You divide by 2, you get x squared equals 64, square root both sides, you get x equals plus or minus 8, but we're only going to look at the plus 8. Or actually the minus will work too up there, so plus or minus 8. Okay? And the plus 8 works right there because negative 8 squared will be positive 64. Okay? Alright. So that's if we have to use a log property. Here's another one I put on here because we're going to have to use both a log property and a little more algebra than we're used to. So here's multiplication. So I have log base 9 x times x plus 24 equals 2. We got to get rid of this log base 9, so we're going to take exponential 9. We're going to put it into the exponential 9. That'll cancel. I have x times x plus 24 equals 81, because 9 squared is 81. Distribute the x. I have x squared plus 24x equals 81. Okay. X squared plus 24x minus 81 equals 0. Okay. Then you just factor this, or I don't know if I can factor that, or or use the quadratic formula or something like that to get your answer. Okay. So just want to show you guys an example where sometimes you might end up with a quadratic. Okay. I probably won't solve them here just to save time. Okay. So anyway, I'll have the notes up there. I'll actually complete this on the notes, and you guys do the rest of the assignment. Thanks. Bye.